Okay, and the steps that are coming up in this lab, we're going to be recording and storing the volume of our sprinkling so that we can chart how much savings we have over time. So we'll keep a history of how much we have sprinkled, how much we would have expected to sprinkle if our sprinkler was not smart, and that'll give us a gauge of how much water we've saved by using this smart sprinkler. And to do that, we're going to need to store and then retrieve that data. And we're going to use a database. We're going to use a database called a SQL database, SQL database. Specifically, we're going to be using a SQLite database, which is a type of SQL database. And before we get started with that, we're going to use this video to walk through some of the very basic commands for using an SQL database. So the first thing we need to do is we need to install the SQLite palette. And so it's this one right here. Say install. And it says my nodes were successfully added. And then I'm going to import the test file that we're going to use for this explanation. And so I have it on my desktop called SQLite demo.json. If you don't have the file on your desktop, but you do have access to this code, you can just as easily copy it for a page, for example, that might look like this. Just copy it from a page that looks like this and paste it into here. You'll get the same result. So I'll say import. And it says it's added one flow, 88 nodes, some configuration nodes, and my new flow is here. And the first thing that I have to do is I have to update this to record to my own database. And we're identifying our database by the port that we're using for IoT Creator because those ports are unique. We want to have a unique database. So I'm going to double click on this SQLite node, and there's a placeholder here. Click Edit. This is a location for a SQLite database with a placeholder for a port number. So if I am on port 1883, I would update that with my port number, leave everything else the same, say update, and then say done. Now, I've only done it for this node, but each of these nodes is referencing the same database, so my change should take in all the other SQLite nodes that are here. So let me explain before I get into this the format and then what we are going to be doing. So the format's the same each time. We are using an inject node to kick off the flow. It's just a timestamp. And then I'll kick off this command. And this command, that's not a great example, but this command is a SQL command. And I'll go through kind of a quick explanation for the majority of these. But in general, they're very basic SQL commands. You can Google them and find out kind of how to write them and change them. And then we pass that command into a SQLite node that indicates our database. So we're taking it from the topic, say properties message.topic, pass along that message, and this receives that message. It's expecting a SQL query, which is how we're writing them. And then we just have a debug node for any errors or any success messages. Just as an additional point of context, the reason that this one is empty is because all we're doing here is we're creating a new database. And to do that, we actually don't need a SQL command. Every other one of these line items, I believe, has a SQL command. And what we'll do in these, what do we have? 11, 12 steps is we're going to go through very basic CRUD functionality, C-R-U-D. CRUD stands for create, read, update, delete, all the basic things that you'll do with a piece of data. And so we will create a new database, create a table in the database, put some data in that table, read that data out of the table, which is the exact same thing we'd be doing if we were trying to graph something. We'd be reading data from a table that we've put in there. We will update that data, delete that data, and then delete the table to finish things off. So let's deploy, just because we just did the import. And the first thing is we're going to create a new SQLite database. So I'll click the inject statement to kick this off. It says it was successfully injected, and if I go to my debug, I don't get a message for the creation of a database. But I can confirm that it worked by going to the next step and trying to create a table inside that database. So I use my inject statement to kick things off, and then I send a command, and this again is a SQL command, saying create a table, call it my first table, and put 3 columns in there: email, first name, and last name. And then we give it some information about how we want to use those columns, which I'm not going to get into. But important to note that it's a table with 3 different columns in it. And we put that into our database. So let's inject this. And now we do get a message. It repeats our SQL statement for us, and then doesn't give us a clear success message. Just says empty here. There's no error. And for a lot of these scenarios, an empty message essentially means success. But let's go ahead and double check that our table has been created. The command here, a little bit different. We're going into a table that describes the tables that a database contains, looking at the names of those tables, and finding a table that's not a default SQLite table, and returning all of those. And when we kick this off, now we get some data back. And if you look at this data, we can see that it returned one name, and that is my first table. That's the table that we created in this step here. So far, steps 1 and 2 have gone successfully. We've confirmed that in step 3. So now let's put some data in that table. So remember, our table is called my first table. It has an email, first name, and last name columns. But those columns so far are empty. There's nothing in them. And so this command says replace into this table in this order, email first, first name, and then last name, these values. So this will be your email, this will be your first name, and this will be your last name. And let's go ahead and run that statement. And we get a message, just says empty, which again is good that it's not an error. So let's read that data and confirm that it's in there. What this is saying is select, asterisk means all, so select all from my first table, every record that's in there, which we expect to be 1 right now. Inject, here's our result. We have 1 object for 1 record, and it's email, first name, and last name. Perfect. Let's go ahead and add some more data to the table just to drive this home. So let's change this. Let's call this Joe Buck. Save and deploy. And let's add that data to the table. Get an empty message. And we read our data from the table. Now we have 2 objects. One is John Smith and one is Joe Buck. So now let's update some data. So our statement is going to read update a table that we indicate, and we want to set the first name to Paul where this condition is matched. And the condition is first name equals John. So it's going to find a record where the first name equals John and set that name to Paul. So we run this, and it gives us an empty message. So let's go back to our read command and read that data out. And if you look, we'll see that now our record that was John Smith has now changed to Paul Smith, but Joe is unchanged. as expected. So we updated data by writing that data explicitly in this command, but it's also useful to update data using a variable. So we're going to add one node here, function node, and all we're going to do here is we're going to set a variable. And the variable is a message that contains actually a little JSON string with a key value pair. So the key is email, and the value is paul.smith@email.com, and passing that along as a message. Then we're going to change our update statement a little bit. Very similar. Update my first table. Set email equal to this value that we're passing in that we got from the node previously, where, again, the condition is matched. And now this first name is Paul, so it's going to find this one and update the email. So let's inject and check on that. And here we have, for our Paul Smith record, the email has now been updated to Paul Smith. Okay, let's delete some data. The D of the CRUD basic commands. And the command is delete, indicate what table it is, and then indicate some sort of a condition. So in this case, it is matching a record where the email is paul.smith and deleting the entire record. So run that. Gives us a message. Let's read again. And we're left with one record, which is the Joe Buck record. The Paul Smith record has been deleted. And lastly, we can delete the table itself. The command is simply drop the table. So run that, and we'll go all the way back up to number 3 to confirm that the table is gone. And sure enough, the command where I'm looking for tables that are not default tables comes back empty. So that table's been deleted. So now we've created a database, created a table, created data inside that table, read that data out, updated that data, and deleted that data. And you are welcome to use these templates when you work with any kind of stored SQL data. And you'll probably find it helpful to Google kind of basic SQL commands as you work with SQL and work with CRUD commands for SQL.